All right, here's another basic verify trig identities. And again, we don't know tons of things at this point, so we're kind of limited to mainly SOHCAHTOA, sine squared plus cosine squared equals 1s, and variation of that fundamental trig identity, and using things like factoring, getting common denominators, things like that. Now, a lot of times when you end up with one of these guys, you tend to switch it into like 1 over sine, 1 over cosine, or cotangent, you might put it as 1 over tangent, or you might put it as cosine over sine. So we tend to get rid of those guys. So I'm going to go ahead and put this as 1 over sine of x minus this over that. And again, I'm focusing on the uglier side. I'm hoping to get this. Now, again, I also know that cosine squared plus sine squared equals 1, so I'm thinking this is going to be a variation of that. And so that's kind of what my goal is to get. All right, so right now, and again, there's tons of ways to do these. I'll do it this way, but again, there's usually more than one way. So if you're like, well, I didn't do it the way you did, it's probably still okay. All right, so I'm going to stick a 1 under there. Again, anytime you have fractions, you probably want to get a common denominator. So we're just going to do sine of x, sine of x. All right, so if I simplify that up there, I get 1 over sine squared of x all over sine of x, and then my big common denominator of sine of x there. So you get complex fractions a lot, and again, that's why algebra is a prereq for this course. So 1 minus sine squared of x over sine of x. All right, so then again, we have that fundamental trig identity, my variable in there, equals 1. All right, so if I subtract the sine squared, I know that that's cosine squared. So I get cosine squared of x all over sine of x all over another sine of x. Okay, so that's where I'm at right now. All right, so at this point, I'm going to put a 1 under here. And again, when you have complex fractions, you get a single fraction over a single fraction, and then you can multiply by the reciprocal. So I'm going to do that, 1 over sine squared of x. Oh, sorry, just 1 over sine x. Sorry about that. So we're jumping ahead. So I get cosine squared of x over sine squared of x, which actually I didn't even need the, a variation of cosine squared plus sine squared equals 1 to get this. I'm just looking at that. I'm like, oh, wow, that is actually the definition of cotangent squared of x. So that leads straight into that. All right, there's other ways of doing this where you do end up using a variation of that, and that would be if you decided to split this into half at the beginning. So if you did cosecant x over sine x minus sine x over sine x, do you see how you're going to end up getting that minus 1? That would be another way to solve it, where you would use a variation on that trig identity. But otherwise, here I'm like, okay, I separated them, got a common denominator, used my cosine squared, did complex fractions, and I actually end up getting cosine squared over sine squared, which is actually cotangent squared of x. So that worked out awesome.